Okay, here we go. Okay, so we need to figure out the length of a line segment given 2 points. 2 points create a line segment. I can find the length of that line segment from those 2 points. I'll give you an equation. There's an equation for it. You will use it a number of times, including on your assignment. Did it go out the window? I think it went out. Oh, there's another one. Okay.
This is going to be your most interesting video, I swear.
It's going to go boom. It's going to make me famous. All over a bumblebee. Okay. How do we... So, here's what we got. We've got a car accident, and it occurred 50 kilometers north of Sturgeon Falls. Okay? So, right here at the X on your sheet. Okay? I know, sorry, the picture ain't great. You can see it a little... Mine's not bad, so if you look up here, you can see it a little bit better. Okay? One of the victims requires specialized surgery that is only performed at hospitals in Sault Ste. Marie, Sault Ste. Marie, I think. Yeah, that's weird it says Sault. Sault Ste. Marie.
That's how it's spelled.
Yeah, that's interesting. I knew the pronunciation, I've never seen it spelled. Sault Ste. Marie. That's just how you pronounce it, I guess. Toronto and Ottawa. A helicopter will fly the injured person directly to the closest of the 3 hospitals. Where should the patient be flown? Okay, so there they are. They've had their accident. Then they need to be flown to either Ottawa, Toronto, or Sault Ste. Marie. Okay. So here, we need to figure out what we're going to do is draw triangles to each of those. Okay? So, I think what they're doing is they're calling each box 50 kilometers. Is there a scale anywhere? Okay. It's approximately, so we're taking a guess here, okay? So, there's Sturgeon Falls, but it said 50 kilometers north, so they're saying each box is approximately 50 kilometers, okay? So, here's what has to happen. To get to Toronto, the helicopter's obviously going to fly from the X to Ottawa, sorry. We'll do Ottawa first. So the helicopter obviously has to fly from the X to Ottawa directly. It's not going to follow some weird path. It's going to take the direct line, okay? To figure out how long that line is, you could draw a triangle. Okay? And then that X piece is going to be approximately, let's say, 50 kilometers. Or we could call it 100. What are they calling it here? You can call it 100. Here, one sec. Let's redraw this bottom piece.
From where to where is 100?
The X down to like from here to here.
Oh.
Okay? So that, we'll call that 100. And then across to get to Ottawa is going to be 50, 100, all the way up to 400 it should be. Okay? What you can do is use like, this is a right angle triangle, is it not? It's kind of nice. It's all starting to, this is kind of good that we've done this in this order, at least for this unit. We can figure out the hypotenuse, can't we? Pythagorean Theorem, right? Here's c squared. C squared has to equal 100 squared plus 400 squared. C squared is equal to 1,000. 10,000, sorry. Plus 16,000.
No, like, oh, is it 16 or?
What's 4 times 4?
It's 160,000.
Oh, sorry.
4 zeros.
1 extra 0. Sorry. I'm running out of room. Is that better? 40. Okay? So then C has to equal the square root of what?
107,000.
Good. Okay. So who is that number for me? These shouldn't take too long, actually. Okay, so 412.3 kilometers. Okay. So that's how far it would take to get to Ottawa. Now, let's do the exact same thing for Sault Ste. Marie. But we'll do it in, I'll do it in purple. Is everybody like okay with what I just did there?
Yeah,
Okay,
is that
it's-
a 5?
Is it what, sorry?
For what C equals, is it 0.5?
0.3.
Okay, that's a 3.
412.3 kilometers. Okay, and I'll do the next one in purple. Same thing here. We're just going to assume Sault Ste. Marie's like kind of the same level as Ottawa. Okay. Right? So it's 100 to go down. And then how far across? We're going to call this one 350. Okay? So you do the math there too. So you can go c squared. We're going to find c squared here. C squared is equal to 100 squared plus 350 squared. So c squared is equal to 100,000 again. Is it 10,000 or 100,000? What did I do earlier? That's what I thought. And then what's the 350 squared?
122,500.
500. Okay, thank you, Aiden. Good? Are we good?
Wait, Mr. Mackay, is Ottawa 400?
Yeah, close, approximately.
Isn't that like big approximation to make?
It is. The whole thing's an approximate. This isn't the point of the lesson. We're just doing something. I'm showing you something for a purpose. It's not for its exactness, it's because of something else. Okay? Yes, Sophia?
What's the second number after?
122,500. Okay? So then we can go c is equal to the square root of what? What is it?
100, you're just adding 10,000, 132,500.
I was just checking. I want to see if you make a mistake. See, I write things wrong, and then I see if you can catch it too.
You sure?
Sometimes yes, sometimes no. I will admit to the mistakes that I do on purpose. Like yesterday. So what's the square root of that number?
364.
Alright, so which one's closer so far? Are we going to Ottawa or are we going to Sault Ste. Marie so far? Okay, we're going to Sault Ste. Marie because that's a smaller number, right? As of right now. But there's one more hospital. It's in Toronto. What's the old expression? Don't count your chickens till they hatch. We don't know if it is or not. Let's see.
Toronto, you probably go
Just
to
everybody relax. It's okay.
on the way.
It's all gonna be okay.
Yeah, you probably still get shot.
Okay? How far down? 100, 200, 300, and I don't know, 375? Is that okay? Approximately? How far over? We call 125? Can you guys see that? Sorry, I know it's horrible.
We already know now that it's further. There's no point in doing it.
375 and 125. Okay? We can do the math on that. We do the same math. Does anybody have a number for that? Just out of curiosity, have anybody already done it? Just give me a number for the red line to Toronto, basically.
395.
Okay, so it's the same work, everybody, okay? Okay, so which one are they going to?
The
The Sioux.
I'm from before.
Oh, right. That's the Sault Ste. Marie. Is that the Wolves? What's the team that's up there?
Greyhound.
Are they-
Greyhounds. That's right. The Greyhounds. That's right. That's right.
Is
That's
this
right.
hockey?
Yeah. From my hockey days. I actually played with the kid whose dad was the scout for that team. Yeah. Okay. I guess we just did all that. How can we determine the distance from the accident site to each of the hospitals? You could apply Pythagorean theorem, basically.
Can you go up for a second?
Yep. Okay. Use your triangles, Pythagorean theorem.
What did you write at the end of Pythagorean?
Theorem.
No, like, what's the end of the word?
M.
That's an M?
That's close enough.
Oh, that's a straight line.
That better?
No, I'm talking about
There you
Pythagorean.
go.
Oh, it's an N. What does Pythagorean end with?
Oh no, it looked like a line.
You don't know?
No,
It's an N.
it was a line. That was not an M. That was a straight line. That was a horizontal line.
Slope was 0. Okay, so all that work could have gone down underneath that space. That's kind of my bad, but anyway, we're using triangles. The idea of what we're going to do here comes from Pythagorean theorem. That's the important part. Okay, the use of triangles. All of a sudden, the entire equation is like, oh my goodness, it makes so much sense. Which, if you just think about it as triangles, nobody has an issue with this. It's just Pythagorean theorem. Just triangles. Okay? So that's the whole thing. That's it. We don't even need to write anything down here. We're just going to write down the triangles. That's the important part. Pythagorean theorem, that's how we found the distance to each of those points. We found the hypotenuse.
So the method does work when it's not the origin?
It doesn't work when it's not the origin. Are you speaking in reference to what? Sorry.
Question that you just scratched at.
Oh, I see. No, it wouldn't. Because it's a different length.
What question did you just scratch out?
This one at the bottom.
So we're not answering this?
Well, okay, the method wouldn't work. You'd have to manipulate the formula, I guess.
So just like no.
Yeah, it just wouldn't work. For a reason, you'll see why in a sec. It has to be a point going to another point. You'll see in a sec of the equation.
What is it saying? The site was not at the origin. What does that imply?
It means it's not like,
That x is on zeros.
yeah, that's not 0, 0.
Oh, because then the y and x values would change.
Yeah, you'll see in a sec. That's not that, you guys just gotta come along here, okay? Once you see the equation, the important part is that we highlight Pythagorean theorem, and then you'll see where the equation comes from, and then hopefully you don't even need me to provide it to you. It just makes so much sense. That's the idea, hopefully. I'm trying to like fast track through this so that you can use it, because that's what matters, right? So, turn your page, if you have not already.
So what did we say for number 2?
Don't worry about it.
Don't worry about it.
It doesn't work. If it's not at the origin, it doesn't work. Okay, here is what happens. You saw on the other side, we used c squared is equal to a squared plus b squared. Yes? Then we saw c was equal to the square root of a squared plus b squared. Okay? If I were to just draw a point over on the grid, right? X and Y, could be anything. We could draw it up here. Okay? And then I connect the origin, as we discussed above, because it always has to be kind of the origin. If I connect those 2 points, that's what we're going to call the hypotenuse, or the d value, right? Or distance or something. Distance, let's say distance. Okay? Then I'm like, okay, the distance or the hypotenuse that we found, like in the accident question, was made up of 2 pieces, right? There was kind of like your vertical piece, up and down, so y. And then we kind of found there was a horizontal piece as well, which we called x.
This is kind of like rise over run.
A little bit. A little bit. You're going to find that rise over run starts popping up. You can see it pop up in all sorts of different little spots. It just doesn't look like rise over run. Okay? Anytime you see a triangle like that, it's kind of rise over run, actually. Okay? So, just in relation to the triangle. I'm purely doing this from the triangle. C was D, so D is equal to, then it doesn't matter what order you pick A and B to be, but it's going to be x squared plus y squared, square rooted. Is anybody like, what is going on right now? This is like Pythagorean theorem with different letters. That's what it is. That represents distance and then x and y. It's Pythagorean theorem. Are we good? Okay. Now, here comes the fun part. If in the event you're given 2 points, like this one and this one, then you can develop the equation below. Because you have like, it's like your midpoint. You know where we found like the difference between the two values and then we divided by 2 and that told us the middle? It's like that. So I have 2 x values and I have 2 y values. Okay? So here it is. I've done a lot of talking. It doesn't need to be as complicated as I'm making it. You just need the equation. The important part is that it comes out of Pythagorean theorem. So D, distance, is equal to square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, to answer Sarah's question of whether or not things work if not from the origin, the top question would not work if that was not the origin. This equation is powerful in the sense that you could plug in any 2 points. It does not need to be the origin, and it works.
What do you mean not need to be the origin? How is the origin?
Okay, so if I were to plug in one of the points as being the origin is what we're calling, for anybody, 0, 0. So what happens if I plug in 0, 0? I get this equation out. I'm going to shrink this down because it's kind of annoying as big as it is. Okay, if I plug in 0, 0, I get this. No, it's just a point. You don't even need that. So where are we? We're back at Pythagorean theorem, which is what we solved the top questions with, was Pythagorean theorem, because we treated the accident site as the origin. That method wouldn't work if we didn't treat the accident as the origin. I have now given you an equation that I don't care what the 2 points are anywhere on the coordinate grid. You can plug them in. It spits out your answer as the distance or length between those 2 points. You just throw in the points that you have. Yes, Sarah, question?
Does it only work for right angle triangles?
So technically, we haven't created a triangle, right? It's just developed from the triangle. All we have is 2 points. We would need a third point to lock it down as a triangle so that there's 3 corners, right? All we have is 2 points, so it's a line. So then we plot in the 2 points that are the endpoints of the line. And it tells us how long that is. That's it. It's kind of cool. Do you want to do a question?
What are you gonna do after this lesson?
Nothing. I'm going to go home.
After this lesson?
Well, I know you got time. You got stuff to work on. I'm going to give you some homework, obviously. We ever done a lesson and not gotten work assigned? Once.
I think maybe one more.
No, don't need the input. Once. Okay. Are we good? Let's do some questions. Again, like this is what it is. You can take it at face value. You can like bog yourself down in the proof. Or you can just choose to use the thing. Just use it. It is what it is. On you go. Okay, we do this to show you where it kind of came from to help some of you memorize it. Okay, well, at least we have an understanding of where it came from. Okay, all you're going to do now is just apply it. Not going to ask you to reproduce that thing. Right? Is that okay? So we got 3 points there. Oh, it's a triangle. You guys have a question that involves a triangle. Interesting. Let's go plot those points. A is at -1, -1. Right there. B is at 2, 0. And C is at 1, 3. It's not that big, eh? It is pretty boring. Okay. C's up here and B is there. Okay. Determine the lengths of the sides. We good? Okay, let's do, I don't know. Yeah, but you can, how are we going to denote this? Let's do distance of AB, line segment AB, okay? Okay, what are we going to do? We're going to plug it into the equation. I'm going to try and write a bit smaller. That's okay.
Instead of D, and then the side length of AB.
Yep. D of line, so the distance of side length AB is the way that reads. Okay, so you're just going to use the equation above. You're just going to type it in. x2 minus x1 squared plus y2 minus y1. Okay? Doesn't matter what order you do it in, as long as it stays consistent. And by that I mean which point you pick to be point 1, point 2. Doesn't matter. Okay? What do I want? I want AB, so this is, I'm going to pick x1, x2, y1, y2. Plug them in. Okay? So you get x2 will be 2 minus -1. You guys gotta be, yeah, you gotta be careful with the signs in here, otherwise you get the wrong numbers, okay? Be careful. y2 is 0 minus -1. Square rooted. Okay? So that's going to equal 2 minus -1 is going to be 3 squared, plus 0 minus -1 will be 1 squared. So I get 9 plus 1 square rooted, which equals to root 10. I would leave that alone. What?
Is that 9H? I can't really read that.
Sorry here. I'll clean it up. Which part right here? Ada?
Oh, that's 9 plus 1.
9 plus 1, yeah.
9H.
Yeah, after I put the square root on in the box, it gets a bit, it's actually not as easy to write on this thing as it is a piece of paper, because the pencil just kind of glides around. There's no friction. It just kind of goes wherever. It's a little bit tricky. I don't know if any of you tried this.
You also get unlimited drives, though.
Yes, I do. Thank you for pointing that out. Okay, are we okay? Okay, so there's the length of side length AB.
Would you not want us to convert that into a decimal?
What's funny is in grade 11, you guys start learning how to deal with the square roots like that. So you can actually simplify that. Maybe not that one specifically, but you can you can start simplifying the square roots, or we call them radicals. You'll do a whole unit on like radicals. Just kind of cool. I like the word radical. It's called radicals. If you open a grade 11 book, you'll see radicals. It's kind of cool. All right, let's do the next one. Let's do the distance between B and C, okay? I'm not going to write the equation every time. I'm just going to start doing stuff, okay? 1 minus 2. You guys can see where the numbers come from because I just want to get through this. Everybody see where those came from? BC, points BC. So 1 minus 2. And then the y values would have been 3 minus 0, okay? So the distance between BC equals 1 minus 2 is negative 1 squared plus 3 squared square rooted root 10. That's nice. How do we know it's not equilateral yet? Okay. Sure. Okay. Everybody okay? Let's do the last one. Distance up. I don't know why it does that sometimes. Distance of CA, line segment CA, or AC. It's going to be equal to the square root of, too big, 1 minus negative 1 squared plus 3 minus negative 1 squared, which equals 1 minus negative 1 is 2 squared. 3 minus negative 1 is plus 4 squared, square rooted, which is going to be equal to square root of 20. Okay? Some of this is very tedious, but I think you guys are going to need to do that on your assignment. Okay? You're going to need to calculate the distance. On your assignment, it's okay to use the decimal values because you actually need to solve something. But okay? You're also going to need the next step here. So you guys know how to do this, though. This is a grade 9 question. Just find the slope between the 2 points. That's all it wants. Just as a precursor, fun fact, just in relation to the last lesson, what are we trying to figure out here by finding the slopes? Just want you to think back to the last lesson, what we talked about, and maybe how we could connect the way that lines intersect to this triangle. Okay, I want you to sit on that question. We obviously don't have an answer yet.
I genuinely didn't even understand your question.
Okay, well, we did a lesson this morning. We talked about the way that lines intersect, or how they're related, if they're parallel or perpendicular or whatever, right? My question to you is, how is that, what we just did this morning, relate to triangles? I want you to sit on that question for a second. Right, because obviously nobody has the answer, but I think we're going to see something cool happen with these two, in this particular question. Okay, I just want you to think about what we did in lesson 2 and how that relates to triangles for a sec, okay? So, let's determine the slopes of these things. One. Let's find the slope of AB. Remember, the slope is always y2 minus y1 over x2 minus x1. Okay? AB should be 0 minus negative 1 over 2 minus negative 1. So that's going to equal 1 over 3. Okay. Let's do the slope of AC next. Or CA, whatever, it doesn't matter. Okay. We're going to go 3 minus negative 1 divided by 1 minus negative 1. Am I losing anybody with this? We all kind of understand what we're doing. Okay, it's a grade 9 topic. All you're doing is picking the points from the points up top. Right? You're just finding the slope between them. So it's 3 minus negative 1 is going to be 4 over 2, which is going to equal 2. Let's do the next one. M of, what's the last one we need? BC. Okay. It's 3 minus 0 over 1 minus 2, which equals 3 over negative 1, which is negative 1/3. 3, sorry. You weren't fast enough, Retta. I caught it before you corrected me. What? Okay. I'm gonna ask again. Have I lost anybody with what's going on here? All we are doing is we're just literally only looking at these points up top, okay? All I'm doing is changing which one I'm calling x1, x2, y1, y2 sort of thing. That's all I'm changing, but I'm looking at these points only for all of this. So if I tell you it's BC, then I'm looking at point B and point C, and I'm applying this equation to it. Same thing up top, right? If I'm talking about AB, then I'm applying AB to those points. Okay? I haven't lost anybody with the slope, right? Okay. Is there anything eye-appealing about the 3 slopes I just wrote on the board, or that you just wrote on your piece of paper?
Yes.
Okay, but I just want everybody to think about it or stare at them for a second. Just trying to trigger a response from this morning's lesson. Anybody? It only works if you stare at your piece of paper.
If no one else wants to answer, I'll just answer.
Okay, Retta, why don't you explain to everybody in layman's terms what it is you see on the page?
I mean, if you look closely at slope of AB and slope of BC, you can see that it's 1/3 and -3. And -3 is also 3 over 1, which is a reciprocal, and it's also negative, so that means it's perpendicular.
Flip it and make it negative. Flip it and make it negative. That is what we call the negative reciprocal, which we said was or corresponded to a perpendicular slope. Okay. Have I lost anybody? Or is anybody just like, I don't even know what that means? It physically means that these 2 lines go do something like this. One goes down like this, and the other one goes up, and they meet at a 90-degree. That's what that means, right? These 2 guys here, okay? Now, in relation to our triangle, what must that mean? It is a right-angled triangle. So you're allowed to use SOHCAHTOA or whatever you want on it. It's a right-angled triangle because 2 of these slopes are negative reciprocals of one another. That must mean that they cross each other at a 90-degree. Okay, so in actuality, the picture I drew there, I could draw the 90-degree on this side, and that should look a lot like this little triangle here, should look a lot like the triangle I drew on the actual grid. Thank you. Okay. So, down at the bottom, we're going to classify the triangle. I just said it was a right angle. Right? 2 of the slopes negative reciprocals. Okay. And then, Retta, what's the other little tidbit of information we know from this? It's isosceles. Oh, what? Is that French?
Yeah. How do you spell isosceles?
We don't speak French in here. I don't know what you said. Is the issue? Okay,
It's the same word.
it's the same. I know. I'm just joking. Like so.
It doesn't look right though.
Well, sometimes I don't think words look right either, but you guys are quite quick to correct me that they.
What does not look right?
Well, that's right. I can tell you that. We'll Google it.
Yeah, Google it.
I would hate to play Scrabble with you.
You did me a phone.
We'd never get anywhere. I'd never be allowed to make a word.
Yeah, you spelled it wrong.
What?
There's an S before the C.
An S before the C? Really? Is it really? Or are you just messing with me?
No, I'm being dead serious.
See what I mean? I'd never win. You'd never let me get any points.
And now it just even looks.
Well, we did just Google it. What do you want?
Yeah, that does look slightly better. It still looks like. Yeah, that does look better.
I'm glad. I can promise you I'm going to sleep either way tonight. It's all good. Okay? That's it, actually. We're not going home yet.